to 4.5. So as you can see, it's the same distance, so if you calculate the z, you see that we get the same thing. And due to the symmetry, it will be the same. But if you didn't have this, you need to calculate for this one. And part D, what is the probability that the battery will last for more than 5 years? So in here, what does it mean? It means that if this is the mu, which is 3, we want to see what is this probability, this shaded area, more than 5 years, which will be the probability, 1 minus the probability of it lasts for less than 5 years, which you have to calculate it. Let's do another example.
The Z value, what could be the range of Z value in the reality?
From minus infinity to plus infinity. And the question is this. This is like a tricky example. A company producing electrical resistors with mean 3 ohms and a standard deviation 0.05 ohm. A buyer sets a specification on the resistors, on the resistance to be 3.0 plus minus 0.01 ohm. On the average, what is the percentage of resistors will be rejected? And the company manufacturing resistor of 3 ohm on an average with an SR deviation of 0.05. Now a person comes and buy, but the person will reject resistors which are not satisfying the 3 plus minus 0.01 ohm. The question is that what is the percentage of the resistors which are being rejected? In other words, what is the probability that the resistors will be rejected? Okay, 2 minutes or so. Now, we have this distribution, the mu is equal to 3, right? And the user, the buyer, will reject if we are 2.99 or 3.01. Less than this or greater than this. So in other words, I have to calculate the probability of the shaded area. Because if I am in this region or in this region, the buyer will reject it. Within this region, I'm alright. Within this region, I'm alright. So let's calculate the Z values. Z of 2.99 is 2.99 minus 3 divided by 0.05, you will get this is minus 2. And Z 3.01 is 3.01 minus 3 divided by 0.05, which you will get it is 2. In other words, I want to know what is so we want to know what is the probability of Z is less than minus 2 and Z is or Z is greater than 2, which means is equal to the probability of Z is less than minus 2 plus the probability of Z is greater than 2. Just a second. And due to symmetry, we know that the probability of Z is less than minus 2 is the same as the probability of Z is greater than 2. Right? So we get that, and this probability is equal to 2 multiplied by probability of Z less than minus 2. Yes, Abdullah.
No, I mean Z it's minus 0.2 to
minus 0.2.
0.2. Yes.
Minus 0.2.
Yes,
Zero.
because the
Maybe the standard deviation should be.
Okay, maybe the standard deviation.
0.5.
Deviation.
No.
Is 0.05. 0.005.
Okay.
Otherwise, we will reject 2 minutes. And by looking at the table, it will be 2 multiplied by minus 2.00. It's 0.02275, which will be this, which means on average 4.5% will be rejected. Now, a distribution like normal distribution is known as two-trail distribution. In other words, we start from minus infinity to plus infinity. Now, there exists other type of, some other continuous distributions, which you will see that they are not two trials distributions. There are not two trials even, there are one trial even. And the first one that we want to talk is this. Log normal distribution. And it is defined as the continuous random variable x has a log normal distribution if the random variable y, which is equal to ln of x, is a normal, has a normal distribution. With mean mu and standard deviation of sigma. The resulting density function for x is, now x has this log normal. In other words, the ln of x will be normal. Now, what is the condition that we have to put? What is the condition that we have to put? if x is less than 0, we are 0 because we don't have the ln of a negative number. And if x is positive, we have this. In other words, if we draw this distribution, we can see that mu1 sigma 1 is less than the mu2 as sigma 2. So as we are reducing the number of mu, we start to go towards the y-axis. So we start from 0. Note, mu and sigma are for normally distributed y, not x. In other words, we are talking about this for mu for y, which is the normal distribution. Because we are substituting ln x by y, and y has a normal distribution, right? Another note is normal distribution has two trial, i.e. it is from minus infinity to plus infinity, but log normal distribution has one trial, i.e. it is from 0 to plus infinity. Not only log normal, there is some other distribution which is much more famous, like exponential distribution, and it's also one trial, and we will do several examples regarding to that one. We have to do an example about the log normal. We will do it tomorrow, and we will talk about the exponential distribution also tomorrow. Then we will start to talk about something which is very important, and it is up to now and up to a few minutes of tomorrow's sessions, we will talk about a random variable x, or a random variable z, or a random variable y. So we are talking about one random variable. Now then we will start to talk what will happen if we have more than one random variable, and if they are so-called joint random variables. Then we will see how we have to handle it, how we have to calculate their expected value. Then we will see that the PDF is different. Then we can come up with the PDF of each of them separately, which we call it marginal distribution functions, and so on. Do you have any question regarding today's material? If not, this is the end of the lecture. You can stop the video.